Good morning, good afternoon, good evening, wherever you are. Welcome to today's webinar, Forget About Data Warehousing, Think Data Fabric. My name is Jacqueline Lewin. I'm a senior analyst with BARC, and I have the honor to be your host today. And with me, I also have the pleasure to hold this webinar together with co-speakers with Chris Papenfuss, who is Area Vice President Central Europe at Agile Data Engine, and Harald App, who is Principal Sales Engineer at Snowflake. We will kick off with kind of a little bit of impulse, kind of let's set the stage. What is data fabric, and why should you actually care? And I'll take over that part for about 15 to 20 minutes, and then I'll hand over to Chris, who will share his and Agile Data Engine's views on the modern data landscape, the challenges there, what data fabric means to them, and what other kinds of things need to be solved. And Chris will then hand over to Harald, who will do the same from his and Snowflake's point of view. And after these speaking parts, we'll wrap up the event with a Q&A with all three of us. And we're really looking forward to your questions. So please be creative and post them in the Q&A area. If your question is geared to a certain speaker on a certain part of the content of their presentation, then please say so in your question who you're actually posting this question to. And yeah, we're really looking forward to interacting with you through this virtual channel. So without further ado, I'll just move forward. So what actually is data fabric? Is it the ultimate solution for modern data architecture? Is it really the revolution some people think it is? Or is it rather an evolution to what we've been doing in data architecture throughout the last decades? So actually, data architecture has been an evolution. We started out with the concept of data warehousing in the late 1980s, and this concept was rather stable for quite a number of years. But it started to change as requirements changed. With when we started focusing on big data and on data science, on raw data, things the traditional data warehouse weren't really geared towards. And this is where the data lake came into play, is somewhere around the early 2010s. And at that time, some people actually thought we don't need a data warehouse anymore because the data lake, as it contains all the raw data we need, can serve all kinds of needs. But as time went on, we actually became aware that that is not true, because the data lake solves some things the data warehouse cannot. But on the other hand, the data lake does not solve things that the data warehouse is pretty good at. So we moved on and saying we like to have the best of both. And that's where the data lakehouse came to play. So a combination of what is good about the data warehouse and what is good about the data lake. Alongside there, we have another concept, though, that's not only focused on data and analytics, but is a general data architecture approach with the data hub. The data hub is something that realizes that we don't only want to provide data from primary data generating systems to the data and analytics platform, but there are other downstream operational applications that want to be fed with data from primary data producing systems as well. And this is where the data hub comes into play. It orchestrates data pipelines and can also synchronize possible copies of data that may reside in the overall data landscape. But basically, all these approaches follow a similar rationale. They're built on the principle that we physically move data from the data producing system, from the primary data producing system to the downstream data consuming systems. And we collect it there and also compile it for the specific needs there. However, we have an expanding variety of data requirements, and they continue to expand. And these fuel the need for heterogeneous data platforms that are geared towards specifically these requirements. And in a distributed data environment with rapidly growing data volumes, extensive data movement quickly becomes unsustainable because it becomes very expensive, it becomes very time intensive, latency becomes an issue as well. And that's where the data fabric comes into the picture. Data fabric says, well, if we have limitations in concerning data movement or time restrictions, why not pick up the notion of leaving the data where it is and accessing it and joining it with other data on the fly as we need it? And to be able to do that, of course, a data fabric has to have an awful lot of metadata that tells the data fabric where the data resides, how it looks like, and how to join it with other data sources. So let's take a closer look. Data warehousing was the concept of pulling in data sources, staging them in an area that was frequently volatile, that said that it's only there as long as the data has not been incorporated into the core warehouse, setting up ETL or ELT processes that pull this data into the core warehouse and into the marts and make it ready for reporting, dashboarding, and these days also self-service. But with the big data era, we started building data lakes and, of course, also data science platforms, which have been for a long time separate platforms because they service different needs than the actual data warehouse platforms. But with building data lakes, we found out data lakes can actually be the follow-up for the staging area because a data lake not only has the raw data, but historizes it in an orderly fashion as well. So why do we need a staging area? We can use a data lake for that. Now, of course, we can but must not also use the concept of data hubs in this scenario. So a data hub can orchestrate the data flows that come from the data sources over the data lakes and go into both the data warehouse and data science platforms. Now, over time now, we're seeing that there is an ongoing functional convergence of data warehouse and data science platforms. Data warehouses are more and more beginning to be a data science platform as well, and vice versa. It's the same. So more and more companies are moving towards one single platform that services both their data warehouse and data science needs, which is where, of course, the data lakehouse comes in, and we say, okay, we'll have one data architecture that serves both needs. Now, inside of the data lakehouse, there is what most people call a medallion architecture. So a layered data architecture with different layers that serve different purposes. Medallions mean I have bronze, silver, and gold. And this architecture is very similar to what we used to have in the data warehouse with the staging area or the data lake, which would be the bronze layer. The core data warehouse layer, which would be the silver layer, and the gold layer that is somewhat similar to the data marts. Now, a data hub, of course, can, but not must be part of this picture. And at the end of the day, we can ask ourselves the question, so does the data lakehouse really solve everything? And data lakehouses are actually, as we see, at the moment, what most people regard as the best practice for data and analytics data architecture. But there are other analytic applications out there as well. There are packaged applications such as Google Analytics. Some operational systems offer reporting and dashboarding functionality embedded, for example, Salesforce, CRM, or in SAP, S4HANA. And on the other hand, there's a growing offering of SaaS applications geared towards analytics use cases, and the number will certainly continue to grow as more and more AI or Gen AI powered applications become available in the next years. And while it might be enough just to access this one source, there will also be a growing need of using the data that is inside these applications together with data that resides in the data warehouse. So how do we solve that? And additionally, some customers, some enterprises feel for their needs, it makes sense to build separated domain-oriented warehouses or lakehouses. And sometimes they're on the same platform, but sometimes they're on different platforms as well. And the best example for that would be maybe an enterprise that does their analytics for finance in SAP BW, and they have other analytics applications based on a non-SAP data warehouse. So how to solve that? And that's where Data Fabric comes into play. Let's just assume I have a data lakehouse, or maybe even more than one, maybe on Azure. I have an ERP system where I'd like to do operational reporting, but also use this operational real-time data for other dashboarding purposes, joined with other data. That could be on-premise or in the cloud, whatever. I might have a customer analytics hub, perhaps on Google. And maybe I also have an IoT platform that maybe could be on AWS. And Data Fabric builds a bridge over them all and builds a central entry point for business users, regardless of what they want to do with the data. And inside all these separated analytics data platforms or data platforms, each of these could have their own data architecture. So the Lakehouse data architecture could be part of the Lakehouse on Azure, but of course an ERP system has its own data architecture. So let's compare very briefly Fabric with Lakehouse. So the data Lakehouse per se creates a copy or ingests a copy of the source systems that are relevant and stores it inside the platform. And Data Fabric, in the first step at least, does not do that. It connects to the original data sources where possible. And of course, I need a data catalog to find my data. The typical data catalog in a lakehouse has an overview over those data sources that have been physically ingested into the platform, but does not have any knowledge of anything that has not been ingested. With the Data Fabric, this is a kind of connected data catalog. It's a data catalog that has knowledge about the distributed data sources and also knows how to integrate and join them as needed. And to do this, of course, a data fabric needs extensive metadata that delivers this information on one hand on the individual data sources, but also is capable of building the knowledge needed to actually integrate and join all these data sources and provide them for the individual needs of the users. And so Data Fabric kind of more follows the notion of moving the compute to the data. which means I'm pushing my computing requirements to the platform where the data resides and using the compute there. Whereas the data lakehouse says I move the data to the compute that resides in the data lakehouse platform. Now, is this a one or the other decision? No, certainly not. As we saw, I can have data lakehouse as one component of the data fabric, and perhaps my data fabric and data lakehouse reside on the same physical platform so that I can use the compute of the data lakehouse, and it still makes sense to build the data lakehouse because I need all these data layers and the optimization of the data for a certain analytics use case. But on the other hand, I still have the freedom of using data from other platforms where that makes sense. So is data fabric finally the answer to all issues? No, certainly not. It's one answer, but we have, of course, many requirements in a modern data landscape. Data fabric is one. Data fabric is an architecture principle, and it's answering the needs of a variety of data requirement, delivering a multimodal data platform, and it's delivering connectivity and interoperability for these. On the other hand, we also have the trend data mesh, which is often kind of mistaken for data fabric or vice versa. But data mesh actually is not an architecture, but rather an organizational principle that is to address scalability concerns in terms of how much of the data can I provide and really utilize? Can I be agile? Can I really answer my new requirements on a near-time basis? And it's geared towards making it possible to integrate domain expertise when fulfilling these analytic needs based on the notion of decentralization, so really organizational. Then we also have the concept of data products and contracts, which of course is part of data mesh, but we also see customers saying, well, we're not up for data mesh right now, but we do think that data products and contracts are a good concept for us because they can be deployed without actually deploying a data mesh. Data products is a data provisioning and data management principle, and it's based on the requirements I want to have trusted discovery, creation, sharing, and shopping and collaboration of data assets that then become data products. And then we have the trend data intelligence, which again is something else, although it is very much also part of data fabric, because data intelligence is a metadata management and activation principle. It says, similar as data fabric provides a data fabric for business data, data intelligence provides a metadata fabric for distributed metadata, kind of like building a catalog of catalogs based on all the metadata I have and require in the enterprise. And it's geared towards efficient and smart data consumption, management, governance, and ops. It has the goal of automating where automation is possible, and making it easier to use and manage the enterprise data landscape. So are these concepts that I just pick one and I'm fine? No, definitely not. These principles are additive. They provide a framework for designing future data landscapes. Their adaptation cannot be just, copied out of a book. They're just concepts. And so I have to think about how to adapt them to my organization's unique needs and the context I'm currently in. Will I start with all four at once? No, probably not. I'll just pick the one that addresses my most pressing pains today, and maybe tomorrow I'll realize, oh, I have new pains. So I have to look at a different piece of the overall framework. So let's wrap that up very briefly. So data fabric is certainly not a revolution, but rather an evolution and an add-on in data architecture. It does not make the data warehouse obsolete. It does not make the data lakehouse obsolete, but rather embraces it and adds an additional layer that makes the distributed data in the enterprise easier to use and faster to use by business users. And the need for different kinds of data and application architecture geared towards varying requirements will remain and continue to grow. So the notion of thinking I can solve all data requirements on one single platform, that is certainly not really realistic as we move forward. The challenge, therefore, in future data architecture is to integrate and orchestrate these different environments as needed based on business requirements. So they don't have to be fully integrated from day one on, but we can move step by step as the business requirements grow. And a very important part of it is providing a seamless experience to the users. I want to be able to optimize my underlying data architecture as needed on a physical level, on a compute level, whatever. And the best part would be, or the best goal would be, if my business users would not even notice that I've changed something. That's the ultimate goal. So that's what I had to share on data fabric. And with that, I would like to pass on to Chris. Welcome on stage, Chris.
Thank you so much, Jacqueline. Good afternoon, everybody. This is Chris dialing in from beautiful Munich this afternoon. And I'm super excited to talk to you about, oops, that was the wrong button here. I'm super excited to talk about our story around enabling data fabric principles with our data platform called Agile Data Engine. So again, my name is Chris. I am in charge of Central Europe at Agile Data Engine. We're a Finnish company. I'll tell you a little bit more about this in just a second. So first of all, I fully agree with what Jacqueline there said. Building a good data platform in your corporation has been a challenge for many, many years, actually for decades. And there is no simple solution to any of the problems simply because every organization has different challenges. And also there is no snake skin oil that can fix all your problems overnight with the push of a button. And so I do want to stick up for our good old friend, the data warehouse, and also for the data lakehouse for that purpose, because I do think, and our company thinks, that there's still a very good purpose for these in your data architecture. And Jacqueline actually also talked about this. It'll be about a mixture of different things, because at the end of the day, a data warehouse or a data lakehouse will be required in many cases simply for legal reasons, legislation, and all these different things. And then, of course, you always need clean and validated data that is also time-stamped. And let's not forget, a data warehouse is a concept and not a technology. And so rather than really trying to get rid of this data warehouse, as the title of this webinar is kind of implying, we should think about what can we do to actually make our existing data warehouses and data lakehouses more efficient. But what I want to do today is not talk about data warehousing per se, but also talk about what you can do in terms of adopting some of the principles around data fabric, because there are some really good ones in there, and we have implemented that in our platform. But to get started, just real quick, chances are not many of you know who we are. Our name is Agile Data Engine. We're actually a Finnish software company, and we got started in 2016. We've been mostly active in the Nordic market for those years, and currently branching out into Central Europe and the rest of the world. And we've been adopting principles of data fabric basically from the beginning. And I want to talk about this today to share some of the insights that we've gained from this, so that maybe you can also think about doing this in your data platform. And what we do is really, we help companies build data platforms. And we do this in, I think, a very unique fashion, whereby we help companies have much longer life cycles for their data platforms and also to get a lot more business value out of them. And again, we've been doing this since 2016. So what is it that we offer? We make it really simple for our customers. We have a single product, which is what we call a data ops hub or a data warehouse automation platform. It is basically an all-in-one platform that allows you to do all the different things that you need to do to build out your data lakehouse or your data warehouse, starting from data modeling, data transformations, workflow orchestration, deployments, really important. I'll briefly talk about this as well. Deployments can be so notoriously difficult and can be one of the linchpins for making or breaking a good data lakehouse. And then, of course, also insights, which is a new concept, which I will introduce you to in just a second. And all this in a low-code fashion. We support multi-clouds to also adopt some of the principles from Fabric here. And of course, we also support Data Vault. So where do we sit? How does this look like? So Agile Data Engine sits on top of the data platform of your choice, whether it's Snowflake, who's presenting together with me today, or Databricks, or any of the other large vendors. So we sit on top and we help build the structures within your data warehouse. We take care of all the automation in there and all the workflow orchestration. So we basically sit on top. We do not ingest any data. We just basically help the data platforms do the important work that they do. And so much about us. So what I want to talk about today is really talk about and share with you how some of the principles from the data fabric construct can really help you build better and more high quality data platforms. And 3 examples for today. One is metadata. Jacqueline has talked about this quite a bit. Automation, also really important. And then transparency and visibility, because at the end of the day, if you want to bring multiple different data sources together, you need to have that transparency and visibility. So let's dive right in. Let's start talking about metadata. For those of you who are old enough to remember a good old library, you might remember there used to be librarians. This was a job, a highly valuable job. Because what a librarian does, a librarian organizes books. They know exactly where to store them. They know exactly how to retrieve them. They're able to provide guidance to the people who come to the library. Without a librarian, a library would just be a big room stacked full of books and nobody would be able to find anything, and there would be a boatload of duplication in there. And that's what metadata is for your data platform as well. Metadata serves as the librarian for your data platform. What would happen if you didn't have metadata? Let me give you a very simple example that happens on a daily basis. Let's say we have a data lakehouse and we want to make a schema change, something that sounds oh so simple. The business calls us and they say, hey, can you just rename a table? It sounds simple on paper, but when you actually really drill down, this can be a very arduous task to do. Number one is you have to research all the kind of downstream and upstream dependencies. You need to look at all the different workflows. You need to figure out when you can safely deploy this into a production environment. You have to merge code. You have to do a lot of testing. And before you know it, this seemingly simple change can get really, really difficult. Once again, it seems like a librarian could really help with this, because in many environments, you have to go in and do this research manually, and this is very time-consuming and scary. This is where metadata can help tremendously. Metadata to me is this proverbial librarian, and metadata in a data lakehouse or in a data warehouse helps you turn chaos into clarity. It helps you identify exactly what is happening in your environment. It knows exactly where things are and what needs to happen. We have adopted this in our platform right from the beginning. And so our system automatically keeps track of all the different metadata elements, starting from the entities, the attributes, the loads, the transformations, testing, and all these different types of things. And this becomes really, really powerful. If we go back to the example of the schema change, in our environment, leveraging the power of metadata, all we have to do is we have to make the model change. And the metadata and the system then fully automated and in a fully automated fashion takes care of all these changes, checks all the different dependencies, it creates the relevant change code required, and then also safely deploys this into production by figuring out when is a good time to actually do this, because the system always knows exactly what is happening in the environment. That is just a very simple example of the power of metadata. So should you use metadata? Absolutely. It is the librarian for your data platform. And from our perspective, it is absolutely vital and critical to have this nowadays if you really want to be effective in working with data. Let's move on to the second principle, automation. This is a really curious one. We talk to a lot of different companies, and very often when we start talking about automation, data engineers often put up their hands and say, like, we don't need automation, we want to code. It's interesting because when you look at our daily lives, we have benefited from automation in many different areas. The whole manufacturing area has become a lot safer since automation was introduced in 17 and 1800. Back in those days, you had to be worried if you would come home alive after working in a factory. Nowadays, this has become really safe. And when I hear data engineers say, like, well, if I don't manually code, then what is my value add? It's almost like saying, if you have a robot in your garden mowing your lawn, does this make you a worse gardener? No, on the contrary, it actually makes you a better gardener because you can focus on the important tasks rather than wasting your time on mowing the lawn, which anybody can do. And that's what automation is all about. So automation in a data platform, from our perspective, extremely important, and we adopt this amply in our platform. Let's take a look at an example if you didn't have automation. One of our favorites, deployments. How many of you, just be honest with yourself, would deploy on a Friday afternoon into a production environment? Chances are many of you would get heart flutters just thinking about this. And indeed, deployments are difficult to do if you do it manually. So there's a lot of different things. You have to check dependencies that I also talked about before. Very often people take shortcuts here and there, which make it difficult. You have little bombs that blow up along the way. You need to merge code, which is always a favorite activity and very time consuming. I personally hate reviewing code that other people have written because they're different styles. And then looking at that and reviewing them and merging them is not a fun activity. And from my perspective, also not very effective use of time. And then, of course, you also have to figure out exactly when can you put things into the production environment, because there are a lot of existing workflows running at the same time. That's where automation can come into play. So automation in a data warehouse provides a ton of value, we found. It's not only automation, also standardization. Just like in manufacturing or in other areas in our lives, automation can make your work a lot easier. It takes off arduous tasks. It helps you save time. It makes you more efficient. But most importantly, it helps increase quality. I mean, honestly, would you buy a luxury car for a lot of money if this car was hand welded? I wouldn't. I mean, I would want to have a state-of-the-art car out of a robot-driven company. Especially here in Germany, we sometimes make fun of cars from other countries where the so-called Spaltmaß is not 100% up to par. But yet in data warehousing or in data lakehousing, sometimes we feel like automation will actually be a detriment to our quality, and we see exactly the opposite here. So automation creates a boatload of value. We are applying automation in our platform amply at various different stages. We try to automate as much as possible so that data engineers can really focus on the important tasks, on those tasks that can make a real impact on the business. And when we come back to the deployment issue, we have managed to fully automate this whole process as well, which becomes literally a push of a button. And there are a lot of different tasks underlying a deployment process that can be automated. And that is, for example, the whole code merge aspect, testing, checking for dependencies and things like that, and also figuring out exactly when you can safely deploy into an environment. And all this automated, of course, once again, this is also aided by the ample use of metadata, because that way the automation knows exactly when it can do certain things and in which way things have to be done. So that is automation. It saves a lot of time, and it drives, most importantly, it drives a lot of quality. And from my perspective, it also puts a lot more enjoyment into the work of a data engineer, because if we stick to the example of a lawnmower, a robotic lawnmower, I think it makes gardening a lot more fun, because I don't have to push the stupid lawnmower for hours on end and rake up the grass after that. The last principle I want to talk about is visibility and transparency. And this is an interesting one when you really think about it. So we in the data world, we enable the business to make better business decisions by creating more visibility and transparency. But honestly, are we actually eating our own dog food, as they say? I don't think we are. Especially in a manual environment where we have manual coding, there's not a lot of transparency into our data platform. And then also at the same time, do you really know exactly what's happening in your environment? Do you really know how effective your processes are? I don't think so. And we want to change this. And this is another important principle from the data fabric construct. So first of all, visibility and transparency. There are multiple different aspects to this. One is if you choose a manual coding approach, most of your models and all your workflows are hidden in numerous files. Technical files that are very, very difficult to understand. If you're a newcomer and you have to sift through hundreds or thousands of files, or lines of code for that matter, it can get really difficult. And I would call this the opposite of a transparent environment. And as a result of that, very often data platforms can lead to data engineers not doing data engineering, but doing data plumbing, because it feels like you're digging deep down in the pipes of your data environment. And that's not really fostering visibility and transparency, and which adds a lot of risk. And especially when you think about this idea that Jacqueline talked about earlier, we want to make it easy to access data on a global level. This is a hindrance here. Visibility and transparency, however, are super, super important for you to build a resilient data environment. As number one is the knowledge transfer. We very often see customers being dependent on so-called data heroes, people who are the only ones who know how certain things work in an environment. And so by having visibility and transparency, you can ensure that this knowledge transfer is possible. It also creates more trust. Let's just face it. I mean, if you don't know what's happening in the system, if it's a black box, having trust in this thing is not really easy. For example, let's say you meet with a doctor and the doctor starts writing in his notebook for hours on end and then basically just gives you a prescription and you have no idea why and what for. You don't have a lot of trust in that doctor. And then, of course, also the other aspect here, which I now want to talk about, is continuous improvement. How many of you data professionals out there collect data or have data available that tell you how solid your development process is and how well your environment is running? I would assume probably not too many. And this is something that we have also introduced to our environment. So, but first of all, by using metadata and automation in Connexy, you can very easily create a lot of transparency and visibility. So for example, in our platform, data lineage and all these different things are automatically generated as a byproduct, and it's always available 24/7 in real time. So there's no need for you to kind of like dig through files. And for a newcomer to come in, it is really, really easy to pick up the pieces and understand what is happening in your data environment. And then the other piece here is continuous improvement. One of our modules is called Data Insights. And what this does is it collects a boatload of data in the background about your environment and also about your development process, so that you always know what is happening and how effective your process is. For example, one of the metrics that a lot of our customers really love is the deployment frequency. How many times are you able to deploy to production? This is a key benchmark for trust in data and for satisfaction from the business, being able to deploy to production, to reduce wait times. And all these things are being collected in the background automatically and being served in a nice visually appealing environment. And we've actually adopted a lot of these metrics from the DORA framework, which comes from DevOps. And our customers have started working with this. They really like what they see, and it helps you literally improve yourself, because at the end of the day, you get what you measure. Professional athletes measure everything about their training, about their competition performances. And why shouldn't we as data professionals do the same thing? After all, we enable the business to collect data and to analyze data about their business. We should do the same thing. And we enable you to do this automatically. So with that, 3 principles from the data fabric, construct. We think this is really super important to leverage these. They're very, very powerful. We see this in our own platform. We've been using those since 2016 and continuously involve them. And therefore, we really recommend that you try focusing on those as well. It is powerful. And at the end of the day, if you want to move towards a data fabric construct, you will need to have these elements in place to make it easier for you to work with data and to deliver more successful projects. So once again, our platform sits on top of the different data platforms, and many of our customers actually use multiple of these in parallel. Jacqueline talked about this also earlier, and we make it easier to make sure that there's consistency between them and that there's also the ability to exchange data between them.